Ever feel like you're seeing fewer and fewer stars in the night sky these days? I mean, we all know light pollution is a thing, but what's wild is how scientists actually measure those changes.
Yeah, it's definitely more complicated than just looking up and being like, huh, yep, it's gotten brighter.
Right. So that's what we're diving into today, all thanks to this new research by Salvador Barra,
Absolutely. And, especially now with so many cities and even entire countries trying to reduce light pollution.
trying to actually, do something about it.
Exactly. Having really accurate measurements is more crucial than ever. And that's what makes this research so interesting, because it digs into why that's actually way harder than it sounds.
So it's not as simple as just, counting up all the streetlights in a city.
Well, that's definitely part of it. I mean, a lot of cities DO keep these big inventories of their streetlights. But
But that can't be the whole story.
exactly. It's like trying to understand a puzzle by only looking at a tiny piece of it.
Yeah.
Because you've got to think about billboards and homes, and I always joke, even those glow-in-the-dark dog collars people put on their pets.
It all adds up.
It really does. So to get a handle on all that light, scientists have to get creative.
Okay, so if counting streetlights isn't enough, what else do they do? Is it I don't know, measuring the brightness of a lamp across the room?
You're on the right track. That's one way, called direct radiance. Basically, you're pointing a sensor right at the light source.
And that sensor could be what, on the ground? Or on a satellite way up in space?
Both. Each has its own pluses and minuses, which we can get into later.
Cool, cool. But, okay, what about that hazy glow you always see over cities at night? That sky glow stuff. That's got to be from light bouncing all over the place, right? Not just coming straight at you.
You got it. That's scattered radiance. It's about measuring the light that's been scattered by everything in the atmosphere. More light generally equals a brighter sky.
Sounds simple enough, but...
But of course, there's a but.
Ha ha ha. There's always a but in science, right? So what's the catch this time?
The atmosphere itself. It's like a scientist's worst nightmare when it comes to getting accurate measurements.
What, really? How so?
Well, imagine you're trying to measure how bright that lamp is.
Right.
But someone keeps messing with a fog machine in the room, cranking it up and down.
Hold on, are you saying that the air itself, the air messes with how we measure light pollution?
100%. This new paper, it really dives deep into that exact problem. The thing is, the atmosphere changes constantly, which makes getting reliable measurements over time super tricky.
Okay, so walk me through this. What's actually changing in the air that throws things off?
Well, there are two main culprits. One is molecular optical depth. It's basically how much those tiny air molecules scatter light.
So even just the air itself can block some light.
Exactly. And things like the weather, air pressure, all that stuff affects it. Then you've got aerosol optical depth.
Is that just a fancy way of saying pollution?
It includes pollution for sure, but it's a wider category. We're talking about anything hanging out in the air, dust, smoke, even sea salt that gets kicked up from the ocean.
Okay, so all that stuff floating around up there. And I'm guessing that stuff changes a lot.
Yeah. Oh, yeah, dramatically.
Yeah.
Even day to day can be totally different, which makes comparing measurements, especially from different years, a real headache.
So let me get this straight. You've got the air itself constantly changing, scattering light in unpredictable ways, making it way harder to get a clear picture of the light pollution situation.
It's a bit like trying to hit a moving target
Yeah.
in a hurricane. Yeah,
That doesn't sound easy.
not at all.
So how do scientists even begin to deal with that? It's not like we can just, control the weather.
Right. If only, right. Well, we can't control it, but we can certainly try to work around it. And to understand how, it helps to go back to those two ways we talked about measuring light.
Right, the direct radiance, like our lamp example, and
Yeah.
then that scattered radiance stuff, the sky glow.
Exactly. Let's start with direct radiance since you brought it up.
Perfect. So with direct radiance, you've got the ground-based sensors and the satellite measurements. What are the, pros and cons of each? When would you use one over the other?
Well, if you're looking at a smaller area like a town, ground-based sensors can be really useful, especially if you can find a spot with a really clear view, no obstructions or anything. You can get some pretty good data, like having a front row seat to that lamp we were talking about.
Makes sense. But I'm guessing they're not so great for really big, spread-out cities.
Yeah, their accuracy drops off pretty quickly the farther away you get. Imagine trying to judge the brightness of that lamp, not from across the room, but from miles away.
Yeah, good luck with that. So that's where satellites come in. They've got that big picture view.
Exactly. And they're way more consistent than ground-based sensors, especially when they're looking straight down. Minimizes the amount of atmosphere the light has to travel through.
Less of that pesky fog machine effect.
Exactly.
Yeah.
But even satellites have their downsides. For one, they're constantly moving, right?
Hmm.
So they can really only capture these snapshots in time, whereas a sensor on the ground can just sit there all night and gather way more data.
Ah, interesting trade-offs there. Okay, so we've got limitations with both the ground-based and the satellite measurements for direct radiance. What about that third one, the scattered radiance, all that sky glow stuff? It seems like that would be even more vulnerable to the atmosphere's whims, right?
You'd think so, wouldn't you? But actually, measuring scattered radiance can be surprisingly effective, under the right circumstances, that is.
Oh, so there are ways to make IT work too. What's the secret?
It all comes down to distance.
Distance. Really? How does that play into it?
Remember our lamp and fog analogy? At a specific distance, those changes in scattering from the fog and the changes in dimming from the light source itself, they can practically cancel each other out.
Wait a minute. Are you serious? So the fog, in a way, makes the measurement more accurate. That seems counterintuitive.
It does, doesn't it? But at that sweet spot, you're right, the measurement ends up being a lot more sensitive to actual changes in the light source itself.
Wow, that is wild. Okay, but I'm going to guess that finding that sweet spot, it can't be easy, right? Especially because you've got big cities with lights spread out over like huge areas. It's not just one lamp anymore.
You're absolutely right. That's the real challenge with this method. Finding the perfect distance is a lot tougher when you're dealing with tons of light sources over a big area.
This is really making me think about light pollution in a whole new way. All this talk about scattering and sweet spots. But I want to shift gears just a little bit. Like, why should all this matter to people who aren't scientists, people
Really?
who aren't out there measuring sky glow for a living?
Oh, I'm glad you brought that up because that's the crucial point, right? This isn't just some abstract scientific puzzle. This is about stuff that affects all of us every day. I mean, think about it. If we can't even measure light pollution accurately, how are we supposed to know if all the efforts to reduce it are actually working?
Yeah, that's a good point.
It'd be like trying to bake a cake, but you never measure any of the ingredients. You might end up with something edible, but
Probably not going to be your best work.
exactly. And the stakes are way higher than a cake, right?
Yeah.
We're talking about like the health of the planet, the well-being of humans and wildlife. Heck, even our ability to do astronomical research. All of that is impacted by light pollution. So having accurate measurements, that's the foundation for making smart decisions about lighting.
So it's like you can't fix what you can't measure.
Exactly.
And it seems like uncertainty is kind of a recurring theme here. And it's not just the atmosphere throwing a wrench in the works, right?
You're right. There are other factors too. Like take the instruments themselves. Sensors, as amazing as they are, they're not perfect. There's always going to be some degree of error there. And then there's the fact that cities themselves are always changing. Like remember those old orange-ish sodium streetlights? A lot of cities have switched over to those newer LEDs.
Yeah.
And that alone, just that one change, makes it a lot trickier to compare measurements over time because the light itself is different now.
Right. It's like you're trying to solve a puzzle, but some of the pieces keep changing shape on you.
Perfectly put.
So for those of us who are like just starting to wrap our heads around all the science behind measuring light pollution, what's the most important thing to take away from all of this?
I'd say it's this. Even small improvements in how we measure light pollution can make a huge difference. It can change how we understand the whole problem, and it can help us find better solutions. And that's what I like about this paper so much. It really emphasizes that. Asking those tough questions, trying new approaches, constantly looking for ways to improve our methods. That's how we make progress.
It's like that old saying, right? Garbage in, garbage out. If you start with bad measurements, you're going to get bad results.
Exactly. And speaking of questioning things, this paper got me thinking about something else too. All this talk about different types of sensors and the specific types of streetlights they were studying. It made me wonder about the role of technology itself.
What do you mean?
Well, do the tools that we use to measure light pollution, do they actually influence the results we get? Like, are we just getting better at measuring it, or is it actually getting worse? Or maybe it's a bit of both.
Ooh, that's an interesting question. Like, could it be that different technologies are better suited for measuring different types of light pollution? And maybe we've been missing something all along because the tools we were using just weren't designed to see it.
That's exactly what I'm getting at. It really makes you think about how even the tools we use to study the world can shape our understanding of it.
It's like those old-fashioned scales, The ones with the little weights.
I know exactly what you mean.
If your scale only measures in pounds, You're going to miss those smaller changes. Like a more precise scale, one that measures in ounces, would give you a totally different picture.
A much more accurate one, for sure. And that's what's so fascinating about this whole thing, right? It's like our understanding of light pollution, it's limited by the tools we have to measure it. We might even be misinterpreting some of that older data because our instruments back then just weren't as good.
Oh, that's a great point. It's like we're looking back at old stuff with fresh eyes and realizing, whoa, we were missing a lot. But that's kind of exciting too, right?
It is exciting. It reminds us that science isn't about having all the answers. It's about like that constant discovery process, always refining our methods, trying new things.
Absolutely. So where do we go from here? What are some of the, I don't know, the big questions scientists are tackling now as they try to develop even better ways to measure light pollution?
Well, one of the biggest challenges is just the sheer variety of light sources out there. Obviously, we've got street lights, but there's also like car headlights, those big illuminated signs, even the lights from inside our homes and offices. It's this constant flood of artificial light spilling out into the environment.
Right. And each one is different, right? You've got different colors, intensities, directions. I mean, measuring the combined impact of all that sounds insanely complicated.
It really is. It's
Yep.
almost like you're trying to measure the ingredients of a cake, but the cake's still baking. Things are constantly changing.
Uh-huh. I love that analogy.
So yeah, we need a more nuanced approach, something
Yeah.
that can really tease apart all those different sources and how they contribute to the overall problem.
Makes sense. And then on top of that, there's the whole challenge of collecting data over long periods. Because light pollution, it's not static, right? It's always fluctuating, even over a single night.
You got it. So ideally, we'd have ways to track those changes in real time. See how things like traffic patterns or even the phases of the moon affect light pollution levels.
That would be amazing. This has been a really incredible deep dive. We've covered so much ground, from counting streetlights to grappling with the very nature of measurement itself. It's really got me thinking. But before we wrap up, for those of us who are fascinated by all this but don't have our own, high-tech lab to measure light, is there anything we can do? Can regular people contribute to the science of light pollution?
Absolutely. And it's easier than you might think. One of the best ways is to become a citizen scientist.
Oh, yeah. I've heard about those programs.
There are some fantastic organizations out there like Globe at Night. They actually rely on volunteers to collect data on light pollution levels all over the world.
So what, you just look up at the sky and report what you see?
Basically, they give you all the instructions you need. All you really need is a smartphone and a clear view of the night sky.
Wow, that's awesome. So you don't have to be a professional astronomer with a fancy telescope to make a real difference.
Not at all. Every single data point that citizen scientist collects helps us get a better handle on this global problem. It's a team effort, for sure.
I love that. It's a good reminder that even small actions can have a big impact. And on that note, I think this is the perfect place to wrap up our deep dive for today. But before we go, one final thought for everyone listening. The next time you're out on a clear night, take a moment to look up at those stars. Appreciate the beauty of a truly dark